All right, last example for this section. This is a definite integral. We have endpoints of integration. We're looking for an area under a curve. And there are basically three ways to do this with correct writing. And I want to show you those three options, and you can choose whichever of these three options you like, but it has to be written out correctly. First of all, the first option is just drop the endpoints and do an indefinite integral. So drop the endpoints, let's do the indefinite integral. The substitution here is u equals x squared over 2, du equals 2x over 2, so just x dx. And so our integral becomes e to the minus u du, which is minus e to the minus u plus c. So that's minus e to the minus x squared over 2 plus c. So that's the antiderivative. Now, since we actually want the definite integral, we can just take that minus e to the minus x squared over 2 and evaluate it at our endpoints 3 and 6. So we can just turn it into an indefinite integral, do the antiderivative, and then use the fundamental theorem of calculus and say the definite integral is the difference of the antiderivative evaluated at these endpoints. So let's see, 6 squared is 36 over 2 is 18, so we have a minus e to the minus 18 minus negative e to the negative 9 halves. So that's e to the minus 9 halves minus e to the minus 18. So that's our answer, and that's one way to do it. Okay, the other two ways, another way that we could do that is 3/6 e to the minus x squared over 2, there's an x dx, is we could make the substitution u equals x squared over 2. It's the same substitution, du equals x dx, and so we could say our integral is equal to the integral from x equals 3 to x equals 6 of e to the minus u du. And we write that x equals 6 and x equals 3 as a reminder that those values correspond to our original variable x and not to our new variable u. So we don't get confused and plug the wrong thing in at the end. Now we have negative e to the negative u from x equals 3 to x equals 6, which is negative e to the negative x squared over 2 from x equals 3 to x equals 6, and we already saw what this is equal to. This is e to the minus 9 halves minus e to the minus 18. So same answer, different way of writing things down, just a matter of preference. But it is important to remember that those endpoints of integration correspond to x and not to u. Because we switch to u, we have to switch back to x before we put those endpoints in. And finally, the third option, 3/6 e to the minus x squared over 2 dx. I forgot that x again. So there it is, the third option. It's the same u substitution. So we get to an integral e to the minus u du, and that was from u equals x squared over 2. And now we can change the endpoints so that they actually do correspond to u. We can say if x equals 3 and plug in, we have a relationship between x and u, so plug into that relationship, then u equals 9 halves. And if x equals 6, then u equals 18. And so we can use those values, 9 halves and 18, as endpoints of integration that actually correspond to u instead of x. So we can change the endpoints so that they go from being endpoints in x to endpoints in u. And that would also be correct. And then we'd have negative e to the minus u from 9 halves to 18, which would give us the same answer that we got before, e to the minus 9 halves minus e to the minus 18. So any of those three ways is just fine, and you can pick a preference there. The trick is making sure we evaluate it at the right endpoints and that we don't get confused between x values and u values. And as long as we do one of these three things, we'll end up with the right answer in the end. That is how we deal with the technique of substitution when we have endpoints of integration, when we're doing a definite integral.